All right, team, let's get into it. So if you're building a RAG system for production, you already know the proof of concept is the easy part, right? The real challenge, the hard part, is making it robust, making it smart, and making it ready for the messy, complex data the real world is going to throw at it. This is our architectural briefing on how we get there.
Look, we all start here. It's RAG 101, the classic index, retrieve, and generate pipeline. You chunk your docs, you embed them, and you pull the top K results. It's a solid foundation, for sure. But as you've probably already figured out, it starts to show cracks really quickly under a real production load.
And yep, here are those cracks. A naive pipeline just falls over when you give it a multi-step question that requires actual synthesis. It totally misses the deep connections between documents. And, maybe worst of all, it's completely blind to the super valuable information that's locked up in images, tables, and diagrams. As your knowledge base gets bigger, retrieval quality starts to tank, and you end up feeding a bunch of irrelevant noise to your generator, which just poisons the final answer.
So, here's our playbook for leveling up. We're going to move from flat text to structured knowledge with something called graph RAG. Then, we'll build in smarter reasoning loops with agentic RAG. After that, we'll teach it to see beyond text with multimodal RAG. And finally, we'll wrap it all up by talking about the critical production trade-offs we have to make to pull this all together.
First up, graph RAG. This is our answer to that lost in a sea of text problem, where simple vector search just can't see the forest for the trees.
Now, think about what's really happening on this slide. This is a huge shift. On the left, you've got flat text retrieval. It sees every document as just an island, a separate chunk of text. But on the right, with graph-based retrieval, we're transforming that flat sea of text into a connected web of entities and their relationships. We stop asking what's similar, and we start asking how are these things actually connected? That's what unlocks true multi-hop reasoning.
So let's be super clear. Graph RAG is not just a different way to index stuff. It's a whole framework that uses the graph itself to model how things are related and to navigate those connections. This gives us a way more accurate and efficient method for pulling together comprehensive context for the model.
And this is a key architectural choice you'll have to make. There are basically two flavors. You can go with a knowledge-based approach, where you're building a formal, structured knowledge graph. Think of it like drawing a super detailed city map from scratch. Or you can use an index-based approach. Here, the graph is more like a hyper-efficient subway map that just helps you navigate the raw text chunks faster. Your choice really depends on what you need: deep, explicit modeling or fast, scalable navigation.
All right, so we've structured our knowledge. Now, we need to get smarter about how we reason over it. This is where agentic RAG comes in, and it's all about solving that one-shot failure problem.
Because that's the real problem, isn't it? For any remotely complex query, like compare product A and product B, or explain the root cause of Z, a single retrieval pass is almost never going to be enough to get all the context you need. It just isn't.
Agentic RAG is a total game changer because it adds a reasoning loop. Instead of this rigid, fixed flow of retrieve then generate, we're giving the system autonomy. It basically becomes a research assistant that can plan its own strategy, decide what tools it needs to use, and, this is key, reflect on whether it actually has enough info to give a good answer. And this visual shows you the different kinds of reasoning loops we can build. You can have an iterative process that keeps refining its answer. You could have a recursive one that breaks a big problem down into smaller subqueries, or even an adaptive agent that decides if retrieval is even the right move. The key engineering pattern here is what's called a hierarchical retrieval interface. This lets the agent make smarter, scaled decisions, choosing between a broad, shallow search or a deep, narrow dive when it needs to. This is how we start to handle real-world complexity. So let's break that loop down into actual steps. First, the agent plans, then it retrieves and acts. But step 4, reflect. This is the secret sauce. This isn't just a quick check. It's where the agent can actually analyze the results it got back and dynamically change its own search queries. It asks itself, was that useful? Should I try a different approach? Only after it's satisfied does it generate the final grounded answer. That reflection step is what makes a system smart instead of brittle.
Okay, we've got better structure, we've got smarter reasoning. Now we have to tackle a massive blind spot in almost every RAG system out there: the fact that our documents are almost never just plain text.
I mean, just think about our own knowledge bases, right? We've got engineering diagrams, financial reports, data sheets. They are packed with critical visual information.
A text-only RAG system is basically reading these documents with its eyes closed. For our system to be truly useful, it has to see the whole document.
So how do we do that without just getting swamped by visual noise? The key concept, the thing to remember, is semantic regions. Instead of just taking a screenshot of a page and chunking it, we use models to intelligently understand the document's layout. We identify the important visual patches, a specific chart here, a single table there, and group them into one meaningful unit for retrieval. It's like precision engineering for our visual data.
And there are two main frameworks leading the charge here. First, Region R. It's all about optimizing retrieval for complex industrial documents by focusing only on those precise semantic regions. This massively improves accuracy and cuts down on all that visual noise. Then you've got RAG Anything. This one uses what's called a dual graph structure to explicitly link text to visuals. So you can literally query the relationship between a paragraph and the chart it's talking about. It unifies the whole thing.
Okay, now for the most important part, where the rubber meets the road. Making this stuff actually work in production. We have to solve the is it working problem. And that means we have to move beyond simple accuracy scores and start talking about robust evaluation and making smart, deliberate trade-offs between performance, cost, and complexity.
Because you can't improve what you can't measure. You're just flying blind without tools like Frames, which evaluates the entire pipeline, factuality, retrieval, and reasoning, or DR2, which lets you isolate retrieval failures from reasoning failures. This is absolutely critical for debugging. It tells you exactly where the problem is. Is our retriever failing to find the right info, or is our generator just failing to understand the perfect context we gave it?
This table right here, this should be your decision-making guide for production. Just look at the trade-offs. Agentic RAG gives you the most power, for sure, especially for complex multi-hop questions. But you're going to pay for it in latency, cost, and a ton of engineering complexity. On the other end of the spectrum, if your use case is simpler and all the context can fit into memory, a long context window model is a much simpler and cheaper way to go. And for those high-throughput apps with lots of repetitive questions, a smart caching layer like RagBoost is going to be your best friend for keeping latency and costs way down. The right architecture depends completely on the problem you're trying to solve.
And this quote pretty much nails where this whole field is headed. We're moving way beyond just text. The core ideas of retrieval and grounding are being adapted to handle everything: images, videos, even source code, to create these incredibly comprehensive knowledge systems.
So, the final question for us as a team is pretty simple. We know our data is complex, we know it's messy, we know it's multimodal. The real question is our RAG architecture actually ready to handle it? Let's get to work.